That's why it's due design over. I learned twice.
Okay, so here's a tank. This is the height of the tank, height of the water in the tank. Let's. You're not overachieving. You're not underachieving, but you're underachieving.
What else supposed to
Yes, diameter of the jet. Yep. And then this has a diameter dt, diameter of the tank. Jet. Oh yeah, I can turn it. Mini monitor. Oh, wait. It's easier this way. I hope. There we go. Is that good?
Yeah, perfect.
Okay. Tank diameter. And this is the jet diameter. Or the exit diameter. Yes, yep. So we're going to find the height as a function of time. So we're going to develop our differential equation. And using the same concepts we talked about before, but we're going to combine conservation of mass and then use Bernoulli's. So let's see how much you remember from Tuesday. What did the conservation of mass state?
That the mass flow rate minus mass flow rate out.
Can you tell me the assumption for that one? Well, yeah. So what you just told me was for steady state. Tell me for non-steady state. Or unsteady. So dm dt equals what? Summation of mass flow rate in and mass out. So we only have we have mass flow rate in minus mass flow rate out. He said that whatever comes in equals what goes out. Oh, but that's for steady state.
Isn't that supposed to be the summation?
Oh yeah, we could do summations. Why didn't I put them in there though?
Because there's only one.
Yeah, there's only one. But in this case, is there any in?
No.
No. So we can cross that one out.
Unless it's raining.
Unless it's raining, sure.
Oh my God. Listen, that's where I am.
So we have that. The MDT equals negative m dot out. But we can keep breaking these up into values, right? Because we're trying to find the rate at which h is changing with function time. And that's where we can change m. So what did we call m last time? The mass. So this is the mass of the water in the tank. Rho AH, correct. I think I heard Shane say that too. Area of the tank, right? So I'll put AT. All right, and then tell me what m dot out is. Yep. Rho of the water times the area of the jet. Those are funny looking J's. And let's
What's the symbol next to that? Oh,
say where?
no, forever. It's just saying this tape. I can't read.
It might be my
My
handwriting.
entire life, not just recent.
Man, You guys must know each other very well. That's probably why Andrew's not in mechanical, right? You're in civil? I don't know. Do you civil folks do that same thing? Or are you civil? Sorry. Did anybody think of that before I said it?
I wish. That was hilarious.
So, anytime I do something with Regal, it's all aboard the Regal train. Because she will make you do things. She is the, what's the head person in the train there? She is the conductor. She's good. All right, so I plugged in M and I plugged in M dot. And what can we cancel now? Rho, because it's incompressible. And say that again?
Why'd you take that like that?
Out of the parenthesis up here? Because rho and AT are constants.
Oh.
Otherwise, you kind of have to do a chain roll. And when you do the chain roll, it's so much easier just right now to think about just take them out. So look at that. That's very similar to what we had before, right? But this time, what are we going to do? We're going to find this in terms of height. Because we know that as it goes down, what happens to the velocity? As the water level it decreases, okay? So, I'm going to zoom back out.
But we're just finding like the time it takes to tank empty, right?
Yep.
So why do we
Because the velocity of the jet is a function of h. Okay? Why? Because we're going to pick this point here as 1. We're going to pick this point coming out as 2. And let's do Bernoulli's with those 2 points. P1 over rho plus V1 squared over 2 plus GZ1 equals P2 over rho plus V2 squared over 2 plus GZ2. See, before in fluids or hydraulics, you did the basic stuff. But now, I want you to start thinking a little bit more in engineering terms, where we can relate, use the same equations, just find that differential equation. That's why you have differential equations class, so you can solve those. So, what can I cancel? GZ2, because that's where our datum is? Sure.
We assume the velocity at the top of the hill.
We can. Why?
small rate?
Yeah, because V1, the velocity of the rate at which it goes down is really small compared to the rate coming out of the jet. In reality, yeah, we should know it, but in engineering terms, this is fine.
Did we say that that thing was exposed to atmosphere?
Yes, both are exposed to atmosphere, so those are canceled. So the velocity of the jet, which is at point 2, is the square root of 2gh. And you've probably seen that before, right? It's familiar in fluids. Now, we can now finish our differential equation. I'm going to write it probably the way you typically would see it.
row. No.
Rows cancel.
Oh, no. Oh, what did I call Z1? Yep, or H, yep. So I called Z1H.
So why did you just want to bring the
Because I want to see from differential equations. Can you classify this for me? First order.
Secondary.
Separable, yep. So first order means that there's only a order one here. Yep. Okay. It's equal to 0, homogeneous, and it's constant coefficients, right? Okay. So you can solve this. There is a way. I'm not going to have you solve it theoretically. You can if you wanted to. Go ahead. Make my day. It doesn't matter. Okay. What I'm going to
Pick it up.
Huh?
I don't want to pick it up.
You don't want to pick one up.
I don't want to find out.
Wait, what?
Was it 5 shots or was it 6? I don't want to find out.
Oh. I'm going to show you an easier way to solve it. It's called numerical, and I want you to solve it numerically. You can do it in MATLAB or you can do it in Excel. It doesn't matter because they're just in equations. And I'm going to show you how to do that right now. Are you ready for this? All right. So here is the tank again. So what do we need to know first? What do we need to know before we solve that differential equation?
The area of the jet tank.
Okay, yep. We need to know the area of the jet and tank, which I will give you. Did I give you anything?
No.
No, I want you to solve it numerically. Wait, I gave it to you, I think, in the homework. So use the homework values.
Oh.
Yeah, there's a homework problem. Yep. So we need to know those, but what else do we need to know? Can you elaborate a little bit more on that? What do you mean by that? That's what we're looking for. We're going to figure out how long it takes to empty, but we're going to solve this from what to what?
From 0 to 0.
So we need to know
0 to whatever.
the weight initial value. Yeah, we need to know at time 0 what is our initial H value, right? We need to know initial conditions. Okay, so that's what we need to know. Just to give you a heads up. Okay, how do I want to start this? Let's see here. Okay, let's start with DH. So we know DH is a differential, right? Instantaneous. But for right now, we can change that to the triangle H, which just states that it's H2 minus H1. So what we're going to do is we're going to break up that differential equation into something that we can write. dt. Well, that's the same thing like this, and you can pick any value you want. So in a numerical solution, you pick a delta t. So I'm going to show you how we write it, and then I'll show you how to do it in MATLAB or Excel. Doesn't matter, all right? So what we're going to do is we're going to take this differential equation in red here, and I'm going to rewrite this like this. H2 minus H1 over delta t equals negative A of the jet, A of t, times 2g, and I'm going to call this H1. I haven't done anything drastic too far yet, right? H1 is our initial value. So if you notice, we know this, right? We know this, we know all these, and we pick that. What are we going to do to this? We're going to rearrange and solve for H2.
So why don't we just do the integral and then have H on one side, T on the other side? And we can have everything at the same time.
Because I want you to do it numerically.
Or what?
Like the integral numbers.
You could.
I'm not trying to look an apple.
No, you could. That's theoretically. I want you to practice programming.
Okay.
That's what I'm trying to practice you. With Excel, you can use Excel or MATLAB, but I want you to practice with this. Yep. Because this is actually how I do all my. I don't solve them analytical anymore, theoretical. I just do numerical. So look. That's our second H value. Right? So as long as we know our initial, which is H1, we can then plug it in here and solve for H2. Okay, what about H3? How do we find the next value of H3?
You do the same thing.
Do the same thing, right? Wow. Try that again. Negative AJ over AT, square root of 2GH2 times delta T plus H2. And you just keep going on and on and on and on. See that there's a pattern here? That's how you know you could use a for loop in programming in C or MATLAB. In Excel, you could just have these, right, and just extract them down. Sure, go right ahead. But it's easier to use a for loop when you find. That's the reason for for loops, is once you find a pattern, you can change this. This is what we call march forward, is actually for difference method in numerical coding. So we find an initial and we keep going forward until the end, what we need. The biggest thing you need to find out is you need to make sure your delta T is small enough where you don't skip a whole lot. Okay? And that's for a whole nother case. Yes?
Is there initial condition to H1?
Initial value is H1. Yep.
Do you have to rearrange to find that?
No, you have to know that. Because that's at time 0. That'll be given. Yep. Yep. So how do you write this in a code? Well, yeah. I'm going to do this right now for you. Yeah.
You may have said this, but why can't you just choose H2 as 0 and just skip all the steps in between? Like, let's say you want to find out how long it takes to end to end.
Yeah, if you change H2 to 0, and you're supposed to be given it. Yeah, you'd simply solve for delta T, right? One over everything else. That would just end up being H2 over AJ over AT.
So you're saying
If you just set that whole equation equal to 0 instead of H2, you can find delta T if you're given H2.
Assuming this was the bottom of the
turn. Yeah, this will give you the turn for it to empty, because if the H2 is 0, that means it's down to the bottom. So
yes.
that would just give you your DT to empty.
That's a good point. Okay, hold on. I got to think about that for a second. No one asked me that before.
Sorry.
No,
Is that what we're trying to find?
yeah, because that's literally finding the answer.
Yeah. That's what I'm going to do.
You're solving, so then you're saying you're solving for delta T?
Yeah,
Yeah,
H on the other side.
Why couldn't you?
I don't think that's going to work.
Why not?
Because,
If you have all those values, though.
I know, but mathematically, because I think it's
It's H1 over AJ.
It's just H1 equals that stuff. Negative.
Negative H1, but
What's the conundrum in your head right now?
So
I'm trying to figure out why it doesn't work. And I know it's not going to work,
I think I might.
but it might be.
Because as the height increases, the mass flow rate is going to decrease as well. Speed, maybe? You know what I mean? It's going to change.
Yes. See? What? Yes.
Well, you aren't using the mass flow rate in that equation.
Yeah,
Yeah, but
okay.
velocity changes though.
What changes as H changes?
You're right. Velocity issue.
because it's actually a nonlinear problem, right?
So then how would you actually decide how to slice it up, your H1, 2, 3, 4? How would you decide how far apart to make
What
it?
you do, okay, so let me answer this one first, and I'll answer yours. I know yours right now, okay? This one, the reason why we can't just do that and solve for delta t is because the velocity, which we defined was radical 2gh, changes as h changes, okay? All right, that is the reason why that won't work. You can get a quick estimate of what we might think it's going to be, but it's not going to be right, okay? Because we know that the speed isn't constant. Sam's question was, how do you know how much to break up H1, H2, H3, H4? The way you do this is you pick a delta t first, okay? So say you picked 1 second, and then you get a graph, okay? The graph should actually look like that, okay? So as it decreases, and then it levels out to the center, all right? When you run this with 1 second, you're going to get a graph. If you change it to 0.1, and you get a different graph, and your numbers are off by, I think typically it's 10 to 20% off, then you got to rerun it again. So you keep changing delta t until like the next set of solutions are within 10% of your data. Then you know you're good. Okay, so that's typically what happens. All right, good questions. Wow, fantastic questions. Where was I? Define. Okay, so in MATLAB, and you can do this in Excel, it doesn't matter. You're going to define dj, dt, g, and delta t. So we'll call it dt. And and then in your solution, I'll do this over here. You need to define the areas, right? Which is just pi d squared over 4. Yep.
Is that all you have to do?
Yeah, that's all you really need to define. So you're going to do the areas, and then this is where, you're also going to pick a final time. Because I'm not going to have you do a while loop. You can do a while loop if you want to, but I'm going to do a for loop. Okay. So this time you may have to keep increasing until you know it's empty. So we're only going to do for loops.
Quick question.
Yep.
Can you use Andrew's estimation then? To
You could.
guess what your final
Sure.
time should be.
Yep, you can use that, and then you're going to have to adjust it. Yep.
Yeah.
Okay, so far nothing too tricky, right? So we're going to then, in your solution, and you could do this in your givens, but I'm going to do it here because it's part of the loop. Say we started with an initial value of 3 meters or 3 feet, doesn't matter. So how do you write h of 1 in MATLAB? Well, it's h parenthesis 1. So we're going to start our matrix, okay? And we're going to start our time at 0. You could do little t or time, it doesn't matter. Yep. So this is our initial time. T of 1. So you're, okay, so you could do this.
He's trying to say should be a 1.
Yes. So we're going to build the time in the for loop. Okay? When we're done, you'll see it. Okay, here's our for loop. For I equals 1, 2, big T over delta T.
You pick whatever delta you want.
Yep. So,
dt is the change in time.
yes. So say we picked 10 seconds as our final time, and we picked delta t as 1 second. How many times is this loop going to do it? 10 times. Okay?
Yeah, you could do 1 to dt, or by dt to t if you wanted to as well, right? Like 1
No.
colon dt colon t, no?
No, because for loops have to do whole numbers. You cannot do, you can't do this. Because it'll give an error, because dt, if it's less than 1, say it's 0.1,
You would have to declare that earlier if you wanted to do that, that's basically, right? Or you still can't.
anytime you do a for loop, you have to have whole numbers. You can't have decimals. You can't have less than 1. It has to be 1, 2, 3, 4. That's how the loop works.
Yeah.
Yep. All right, so
What's that last one you wrote down?
which one? The one I erased?
I equals 1.
Yep. So this is the loop. In MATLAB, this is the for loop. This is our loop indicator. We're going to start with 1, and we're going to go how many times? T over big T, whatever you pick. So here is how we establish h of 2, or h of 3, or 4, or 5. We take I, in this case is 1, and we add 1, so it's 2. Equals negative aj over at times 2g, and this would be h of what? What did we use in our equation? H of 1. So it would be h of I. Because say I is 1. Yep. And then this is times delta t plus h of what?
Delta T would be dt.
Yep. H of I. Why? Because that's what we are used for 1. So I'm hoping you see a correlation from this to the 3 or 2 equations I wrote up in red before. And I'll review this. Actually, let's do that right now. If I is 1,
So I is just your interval.
it's just your interval for the for loop. Yep. So we're grabbing h of 1 here, and this is actually developing our second h value. So tell me how to write time. How would we write the line here to establish our next time?
T of I equals 1.
Keep going. Not quite right. Time of what equals
Oh,
I plus 1 equals time of I, yep, plus
Like the last
time of d, or dt.
dt, right?
Yeah, because that's going to be.
Because our dt is 1, 2, 3, whatever we pick. So this is how it's establishing our next set of times. Our first time plus a delta t. And then we're done with the loop. That's it. That is how you do this differential equation numerically.
So that's one more problem.
That is, I think, number 2. Is it number 2? Do you remember?
Oh, yeah, number 2 would deal with
So we've done it. You just got to program it. You can do it in MATLAB or in Excel. These are your like equations that you can just kind of extract. I don't know. Can you do for loops in Excel?
The dragging it is for loops when you drag it down, basically.
Okay, that
This-
kind of
for
is
this
for
value,
loop.
This
Yeah.
happens for that value.
Yeah.
Yeah, I did the interval.
Yeah, you could do that. I don't care. Yes, Andrew, you have a question?
Yeah.
Yeah.
Was the object of this problem just to find the change in time, or were we giving the area of the jet and the tanks?
Yeah, I think so.
Okay.
Yeah, everything was given in that homework problem.
Yeah.
Yeah, we're trying to find the time.
So we're supposed to plot this?
Yeah, how do you plot it? Figure?
If you wouldn't have asked, you wouldn't have had it.
No.
I actually do know.
Has anybody used my figure format function yet?
I haven't.
No. Okay. You need to. Let me show you what it is, because